Certainly the most important rule for differentiation in calculus is arguably the chain rule. The chain rule says this: if we have d dx, the derivative of f of g of x, so we have a function internal to another function, that derivative is f prime of the outside function times the derivative of the inside function. So this is what we have to kind of figure out. We have to kind of figure out, can we see that? So this is what I'm going to look at right now. I'm just going to try to diagram this a little bit. So this is what I'm seeing as I'm looking at this. I'm like, okay, I'm going to try to see this as two different functions. So here's one function right here. This is the outer function, and part of it is not as obvious as the other part. This 3, I think, is obvious, but this 2 is part of it also, isn't it? Because remember that radicals can be turned into rational exponents. So all I'm going to do here is this, if you don't mind. I'm going to rewrite this function. I'm going to rewrite the function as f of x. It has to be an equivalent function, right? And I'm going to say that that is the same as x squared minus 1 to the 2/3 power. If you're not clear on how I got to this from this, please go check out my video on rational exponents. But I guess really quickly, that the nth root of x to the mth power is the same as x to the m over n power here. All right, here's the numerator, here's the denominator. So that's how I did that. Now maybe you can see that we have two pieces of the function here. So all I'm going to do now is I'm going to start differentiating. So I'm going to work on this part first. I'm not going to do anything with this inside piece, and some people use this use substitution, and that's a great idea, but I don't think it's always necessary. Let's give it a try. So I'm going to use the power rule here. I'm going to bring this thing down, so 2/3. This is a 1 out in front, so 2/3 times 1 is 2/3, isn't it? Times my inside function. And then if you remember, we decrement this exponent, so I'm just going to subtract 1 here, right? Always subtract 1. I just put it in 3 over 3. And that would give us 2/3 minus 3/3 is negative 1/3. So far, so good, I think. Hopefully we can agree that this is the derivative of the outside. We haven't done anything with the inside yet. We're going to leave this piece in here. And then out here, right, this is g prime at x here. So now we're supposed to multiply by g prime at x. So this multiplication sign is this one right here. And what is the derivative of the inside? Well, the first derivative of x squared is 2x, isn't it? And the first derivative of negative 1 is 0, so plus 0. So I'm really hoping that you can see that this, you guys, is this. And that this is that. And all I did was take a rule and just applied it a little bit, okay? I can simplify here. Currently there are 3 factors: this thing, and this thing. We know that there's a commutative property of multiplication, so I'm going to commute a little bit here. And I'm going to do 2x times 2/3, which is 4/3 x, isn't it? 4/3 x. And also I happen to know that we have this negative exponent here, and we know that negative exponent create fractions, not negative numbers. So what I'm going to do is take the reciprocal of this, so times 1 over, now the 1/3 power, so it's the cubed root, isn't it? Cubed root of x squared minus 1. If I multiply all that stuff together, then quickly we'd get this. Remember, this is up in the numerator, so we would get 4x, right? We get 4 times x times 1 is 4x, so 4x over, this is in the denominator, this is in the denominator, so 3 cube roots of x squared minus 1. And that is our f prime at x. All right? I hope it was helpful. I know this is really tough stuff, and what I want you to know is that if you get this put away, you're going to get really, really good at this. So please don't give up. This is a battle worth fighting, so keep it up. Subscribe.